let's get started. Today I'd like to tell you a little bit about dispatcher testing. As from my perspective, this is one of the aspects that is quite often overlooked in the pretty much every single project I worked on. And after a while, I just decided to do something about it. But some of you may be like, well, dispatcher is like a one-off setup, right? You set it once, and it very rarely changes, so why to invest any time and effort into building something that will allow you to test that? Or maybe your perspective is that it just doesn't do much and that the testing is not worth it. Or maybe you, in general, consider such an idea as an over-engineering. I'm going to show you some evidence that you may reconsider your approach. So just a quick recap. I know that some of you have seen that, or probably vast majority of you. But that was an e-commerce project. AEM was that was a cloud version of AEM. It was a headless, totally headless API that's supposed to serve just JSON. The whole API was designed to be stateless, and it was meant to be 100% cacheable. It was designed this way. So yeah, API design, as it's been said earlier, is quite important. And we have a bunch of HTTP clients which will play a role here. So that's the big picture. So yeah, AEM is on the right-hand side. It serves JSON. It is being consumed by Next, the server-side rendering component, and that goes to the browser, which runs the Vue.js code. And of course, from the browser, we have those calls to AEM directly to fulfill the hydration requirement. And that's the JSON. You already know that JSON never breaks, is always a rock-solid response. So what could possibly go wrong with JSON? Maybe not JSON, but dispatcher itself is like enough about JSON. So first of all those modifications that you do to your incoming requests and responses, so all those rewrites, header injections, header modifications, that would be the very first thing. Then the caching itself. Does dispatcher cache what it's supposed to cache? Does it inject all the headers that will influence CDN caching? What about cache bypassing? That is often an overlooked topic. Can you bypass cache? Under what circumstances? Is it easy? Is it hard? Is it per environment setting? Or maybe on dev you'd like to bypass cache easily. On stage and prod that's supposed to be a little bit harder. What about the filtering and security? And there are like two schools of thought here. People either prefer rewrites or filters. Does dispatcher block all it's supposed to block? And error handling. If you send a request, if AEM replies with like 403 or 404 or 500, is it being handled correctly by dispatcher? So there's quite a few areas that you may cover with your tests. And I was looking for something that is well suited to this. And one of the first requirements is that it's supposed to be simple. I mean, like something that has a very simple mental model, so you don't need to get a degree to actually work with this. It's supposed to be fast, so in order to test dispatcher quickly, that essentially means that you just can't allow for AEM to be included in that pipeline just because it takes so much time to spin up. But for the sake of this experiment, it is totally OK to just deal with AEM mocks. It's supposed to be also easy to maintain and extend. So like when you look at the code or the testing code, it should be immediately obvious to you how to do something extra, or how to add another test or modify an existing one. And last but not least, it's supposed to be something that I can easily plug into my existing CI/CD pipeline, just to get some confidence that the change that I just introduced doesn't really introduce any regression, but it actually works as it's supposed to. So after a bit of a research, I decided on this. Of course, there's like a million of tools on the market. What to do, how to do it. It's totally up to you, but I find that this is something that really fits here. So first of all, on the left-hand side, you can see Hurl. I'm going to explain what it is in a second. So that's our testing tool. In the middle, you have dispatcher, and on the right-hand side, there's a man-in-the-middle proxy, yet another tool that is essentially an AEM mock, AEM publish mock in this case, and it serves a bunch of JSON. So a little bit about those tools. So first of all, what is that hurl thing? It's an HTTP command line client, which doesn't sound really exciting, as there's plenty of HTTP clients. But it is also HTTP testing tool, which is exactly what we want to do here. We want to test HTTP flows. It is written in Rust and based on libcurl. And libcurl is like a golden standard when it comes to following the HTTP standards and like essentially behaving as you would expect, as like that's the library that powers curl. Of course, we have dispatcher. That's the official image, Docker image that comes with SDK. And man-in-the-middle proxy, that mitten proxy thing. This is a Python-based tool that is like a Swiss Army knife. I use it a lot in different contexts. But here it is essentially serving a set of files from a file system. So the request comes in, and instead of proxying that to AEM, it just serves those and applies some minor modifications to response body and response header sometimes. All right, so let's try to build something with that tool set. So we're going to start simple. Let's say that we're going to request first JSON. Let's say that was the entry point that I presented earlier. So you send a request, you expect 200. You expect that you're going to get a valid JSON. And it's supposed to be cached by dispatcher as well. When you send a second request to the exact same URL, if you're using conditional gets, you would expect a 304 if there were no changes to the actual resource that you're about to request. You should get an empty body, as 304 is a body-less response. And that response should supposed to be served out of a dispatcher cache. So there should be no AEM request at all, just because like we requested it before, so it should be already there and should be served directly by dispatcher. So that's how it would look like. So on the left-hand side, we have that Vue.js application. On the right-hand side, we have AEM. You can see that there is a country index.json request. It goes to AEM. It returns a 200 response. The most important part here is the E tag here. It contains ABCDE string. We're going to need that for the conditional request later. So in the conditional request, so if you repeat the request, that's what your browser would do normally if you have E tag or last modified, and normally you do. So your browser will copy the value from the E tag and inject that in if non-match header. That will go to your application, in this case AEM, and you would expect a 304 without any body with the same E tag. There was no changes, so super simple flow. So let's try to build something like this in hurl. Hurl has its own file format, but it is like that simple. So it doesn't really require any extra introduction. It should be immediately obvious what it does. So we need to send a first request. That's a GET request to this URL. So that's what it does. We just literally type in GET and the URL. We expect 200. So we say that, hey, that should be 200. Simple as this. And of course, we'd like to set a few assertions. Of course, we said that it's supposed to be a valid JSON. So we inspect the content type header, the one that we received back in the response, that it's supposed to be a JSON. And of course, such a check is super naive, as like that's just the header value. It can be anything. So we can also inspect whether the JSON body that we received is a valid JSON. So we can inspect, hey, is this particular key out there? Does it exist? Does it contain the right value? So that's what you can do easily. And last but not least, here, we need to capture the E tag value just to simulate that conditional get later. So second request, we are still in the same file. We send the same request. Since we saved that E tag into a variable, that E tag variable, we just reference this variable in if non-match header, and that's how you add a custom header to the request. We expect a 304, and we do an assertion that, hey, that's the same E tag as before. Simple as this. How to run it? That's how you run it. Hurl --test and the file name. So fairly easy. And when you look at this, it's not like super helpful. You have no idea what actually got requested, how long it took, whether there were any warnings or anything like that. But there's a bunch of things that you can do to improve that verbosity of hurl. So there's, of course, verbose flags. You can control how verbose that's supposed to be. You can generate a good old JUnit XML if your CI respects that and like checks whether all your tests passed or not. And you can generate an HTML as well. I mean, like proper HTML report. This is how it looks like. So you have access to all metrics, like, hey, how long DNS lookup took, or whether there was any TLS warning or anything like that. So you can essentially, just by browsing through that, you can see all raw requests and responses, which is quite handy to debug. But some of you probably noticed that I intentionally didn't include compression in the request. So let's see what's going to happen if we add a compression here. I mean, like accept encoding header, as that's what essentially means here. So that's the same request as before, but we have an accept encoding header, which says, hey, I support compression, so dear server, if you support compression, just give me a compressed response back. And that's what happens. You're going to get a response, a compressed response. There's a content encoding header, which says gzip, and we have an e tag as well, but this time it looks different than before. There is that -gzip suffix, which is going to play a role here. And I'm going to explain where it came from in a second. So now we send a second request. So the same exact pattern. We use the e tag value in the if non-match header. And we would expect a 304 as well. But that's not going to be a 304. It's going to be 200. And some of you may wonder, like, that it shouldn't be like that. I mean, like, it just doesn't work like this. And in order to do that in Hurl, you don't really need to modify the file, since it was based on the libcurl library. You just need to add that -- compressed, same as in curl. Or if you, let's say, need to proxy everything via a special proxy server, you can just easily do that here as well. And regarding those conditional gets and why it was 200 this time. So in order to understand what happened, first of all, let's try to analyze how the get response is actually generated. So first of all, we need to read the body, either from a file or from memory or from a network stream, whatever. We just read the body. And in our case, we use a checksum of file contents using that file etag digest setting in our Apache server. So the etag is calculated out of the response body that we just read. And then our compression module kicks in, and it kicks in at the very end of the processing. So it's gonna, since it's gonna change the body, you should reflect that in your etag header. It's like that's no longer a raw plain text. I mean, like a JSON in plain text. It's gonna be a binary. It's gonna be a compressed response. So that's what happens when the response gets generated. But what happens when the second request comes in? So, of course, Apache, it's not even dispatcher, it's Apache itself. It reads the request, then the mod core kicks in, and it compares the value from if non-match header, and it calculates the body, the checksum of the body again. And in this case, in our header, we had ABCDE gzip, and of course, the content of the file, it's not compressed. It's going to be just ABCDE, so they do not match, so we can't return 304. And you might wonder why there was no mod deflate playing any role here. Like, we're not sending any response yet. We're just analyzing the request. So we do not need to decompress the request. So mod deflate does not really do anything at this stage. And it turned out that this is a quite old bug in Apache web server. I'm not sure how long that is, but a couple years definitely. There's an open ticket regarding this. And in order to deal with that, you actually need to strip out that gzip suffix upon request arrival. As otherwise, you're not going to handle 304s correctly, all those conditional gets. So if you'd like to handle 304s correctly, that's the line you should add to your config. But some of you may wonder, like, hey, you also mentioned that we're going to check whether that was served out of cache or not. And there was so far nothing about that. And you're right. And there are, of course, different techniques how you can check whether something got cached or was served off of dispatcher cache. But the first idea that people usually say, hey, we can check the logs. But that's totally not practical. I mean, like, how can you check the logs in a reliable way in a pipeline that's supposed to run in the background, like, with every deployment of yours? But there's a different approach how you can do that. You can just let dispatcher talk and let it be a little bit more verbose. And what do I mean by that? You can essentially inject a set of special headers in your response that will tell you what a given response was served off of cache, what dispatcher did about it, what was the actual path from dispatcher perspective. So if you're rewriting anything, you can do things like that. And of course, that is not something that is out of the box. However, there's one special parameter built in dispatcher config, that /info, I believe, that's how it is called, which is supposed to do something similar, but it is, well, kind of broken. Does not really do what it's supposed to. So I gave it a try, and I submitted a few tickets, but it's just broken. So there's an alternative to that, and that's how you can achieve all those extra information and see all that metadata in your HTTP response. There's a set of variables. I believe that all of them are not really documented, so that dispatcher colon backend, dispatcher colon cache, and so on. So there's a set of variables that you can just set, and that will reveal what actually happened with your request from the dispatcher standpoint. So if you'd like to simulate all of that in our curl file, there's a few additions here. So first of all, we have that header check at the top, x dispatcher cache equals miss, as that was the very first request, so there was nothing in the cache. And in the second request, we have that x dispatcher cache equals hit, because that's the second request, and there's a response supposed to be served off of dispatcher cache directly. And of course, there's also a little fix for that gzip suffix here, just to handle it correctly. And of course, that would be way too easy. There were a few interesting ETAG twists as well. So let's try to see what else can be broken with ETAGs. So that is the setup that we have. We have a bunch of Vue.js applications on the left-hand side. We have dev1, dev2, dev3 environments. In fact, we have like dozens of those, simply because, just like I said, on Monday, every single merge request translates to a unique environment. So we have quite a few of those. And every single environment just talks to the same AM environment, as you can see on the right-hand side. So we're going to see a pretty standard cross-origin resource sharing request with that origin header in place. So multiple web front ends will talk to the same AM environments. That's exactly the setup that we have. So what happens when you have such a setup? So N-to-1, essentially, mapping here. So let's say that on the right-hand or left-hand side, you can see someone's machine, someone's browser. There are two tabs, dev1 and dev2. Someone just visited the site. We have Fastly in the middle, which is the built-in Fastly in AM as a cloud. And it uses API-example.com. And on the right-hand side, we have AM. So let's say that someone typed in dev1 example.com. The request goes to Fastly. And for the sake of this exercise, we're going to assume that all the caching layers are empty. So yeah, request came in, Fastly doesn't have it in its cache, so it's going to proxy that to dispatcher and AM effectively. And we're going to generate a response. Since we do trust that dev1 example.com, we're going to see the access control allo origin header in the response. And we're going to see some ETAG. For the sake of brevity, I'm going to skip that gzip part. So that's how it's going to look like. And of course, that's going to be cached, right? So there's a cache label here. So Fastly will say, hey, I didn't have it, now I have it, so I'm going to cache it. And that response will be proxied back to your browser. And your browser will also cache that because we have that cache control header here. So it will land in your browser cache as well. So now you open a new tab, you go to the same URL, and there will be that asynchronous call to AM. That will go to Fastly. And as you can see here, there's one difference in comparison to the first one. So there's that if non-match header, just because like we had such a response before. So browser tries to optimize that. Hey, maybe for dev2, that's going to be the same object as for dev1. So I'm just going to give it a try and insert that if non-match header in the request. And of course, the origin header will be different because we're on a different environment. So Fastly receives that, and it says, hey, you have that vary header in the response, accept encoding and origin. So that's a different origin. I don't know anything about that, so I need to request AEM again, just because this is a different origin, and that's how vari header works. It's going to go to AEM. AEM will prepare the exact same response as before. Of course, the values will be different. The access control allo origin header will be different. And ETAG will be the same because that's the same JSON, right? We do not change the body at all. Fastly, we will cache that eventually as like, hey, that's a different variation of the same object. I mean, like the URL is the same, but that's a different variation. And that response will eventually go back to the browser. And in the browser, I'm not sure if you can see that, over here, there is a course error. And some of you may wonder, like, how on earth that's even possible? But yeah, it is possible. That happened to us. So what actually went wrong? First of all, that was the first eye-striking thing, that when you disable browser cache, it just works. So that may indicate that, hey, the browser caching is broken. But whenever such an idea pops up in anybody's head, if this is the browser problem, it's nearly certain that someone else already experienced that, or maybe that is already fixed. So this is something like, hey, something is broken in TCP. It's probably not. It's you. So when you disable cache and it works, that doesn't really mean that something is broken with browser cache. As I said, CDN supports multiple variations of the same URL. So on those two cases, we had the exact same URL, just different set of request headers and response headers eventually. So CDN behaves as it's supposed to. But there is the one difference. So CDN can support multiple variations for a given URL. In the browser, the implementation is different. There is just one slot for a given URL or given variation. So browser does respect the vari header and those different variations, but there's just one slot per URL. And when 304 response gets generated, as per HTTP standard, not all headers are mandatory, and that access control allo origin is definitely not mandatory in this case. So we got a 304 response without access control allo origin, and the browser said, hey, apparently that site doesn't trust me, so I just can't give you anything. So is this ETAG's fault again? Yes, it is. So what are the rules? ETAG and vari header, they must come hand in hand. So if you vary on something like accept encoding, origin, accept language, anything, or custom header, that has to be reflected in your ETAG. So response body checksum on its own is definitely not enough. So you need to cover all those variations, so things like course headers, encoding, language, whatever else is in your vari header, that has to be reflected in the ETAG eventually. As otherwise, you're going to see something like this sooner or later. Of course, it depends on your setup. If you do not need course, you're not going to see that. But if you do need that, then, well, that's going to happen to you. So in practice, that's how it works. If you request the URL without any origin header, you should get one ETAG over here. If you send dev1, you should get something like this. So we essentially add a prefix to the whole ETAG. And if you change the origin, which is also trusted, then you can see that the prefix here is different than above. All right, so let's simulate that in Hurl. So that's the first request. We just send a request without any origin header. We expect that there will be no access control allo origin, so we said it doesn't exist, and we're going to save the ETAG for further processing. We send a second request to dev1, so we have that origin here. That's the request header. We expect 200. We're going to save the ETAG. We expect the access control allo origin to be present. And finally, the ETAG should be different than in the first case, so we just do a simple comparison. Hey, it's supposed to be different. And we just repeat the same for dev2. In this case, it should be different than the first and the second ETAG, just because that's a different variation. And there will be one extra incident that we had. But before we got to that, we need to introduce a few things first. So in the cloud, there's quite a few domains, and some of them are like vaguely documented. So of course, you have that standard publish, blah, 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 number of your environment, number of your program, adobecloud.com. So that goes to your CDN. That's the built-in domain, the standard one. Of course, you can have a set of custom ones. That's also a possibility. That also goes to CDN. I mean, like Fastly, the built-in Fastly in front of AEM as a cloud service. But there's also Adobe Cloud.net, which is used in a very specific context. And this one is pointed at your Kubernetes ingress, or actually the Kubernetes that powers the whole AEM as a cloud thing. So you can actually give it a try. When you replace the .com from the .com URL, you replace the last part with .net, you're going to get 403 because this is not a public URL. But it exists. Of course, you have localhost for invalidation purposes, and probably some other things. That goes to, I mean, like the localhost is mainly used within the Kubernetes pod. So there's a dispatcher publish pod, and the localhost is being used there. And there's a bunch of few other domains, like there are a set of special domains for auto upgrade capability, but we're not going to discuss about those. And of course, we have a set of layers. So there's a CDN, there's Kubernetes ingress, there's dispatcher and AEM, and like it really matters which host header goes where. So how did we end up with cache poisoning? That was actually pretty funny. So first of all, you've probably noticed that we are using absolute URLs in a response body. So the full URL that you can just click on, and that's going to work. And there are two sources of external domains. So the way we generate those domains, there are two ways how that can happen. So first of all, we're just going to read that out of the host header. That's the very simple approach. Or when there's no request and we still need to render an absolute URL in the code or in any other place, we have a fallback to an OSGI config, which stores or references Cloud Manager variable that essentially says, hey, if you don't know, if there's no request, there's always a fallback you can use. And our API functional, or our functional test, the test that is being triggered in scope with your Cloud Manager pipeline, it was essentially an API crawling. So we crawled through the entire API since we can do it. So we just provided the entry point and crawled through the entire API just to check if all the links are working correctly. So what actually happened? So on the left-hand side, you can see that there's Fastly with two domains, apiexample.com, that's the custom domain, and the default one, publish, pe, blah, 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 adobecloud.com. There's AEM as a cloud in the middle, and on the right-hand side, there's Cloud Manager functional test. So Cloud Manager functional test, it uses those .NET domains. So that's not actually something that you can configure. It's just the URL that is being attached to your Maven config. Like this is a Maven execution at the very end of the day. So that's going to be used in your Cloud Manager test. So you're going to request this, and since we read the value from the host header, our AEM will generate an absolute URL that points to Adobe AEM Cloud.net in the response body. That's going to be cached. There will be another URL that our crawler will read out of that response body. It's going to be requested, and that cycle will repeat several times, and our cache will be filled with those JSONs. And now, when the response or request comes in, there's no user here, but you can imagine that that was requested by the user. The host is apiexample.com, but there's an object for entry point.json already in the cache, and that points to Adobe AEM Cloud.net, which is not available and returns 403 unless you're connecting from a network that is trusted. There were other situations here, but that was probably the most prominent one. So it's super easy to cache incorrect data if different domains are being used. I know that some work is being done by Adobe to mitigate that, to essentially avoid using those dummy .NET domains. So hopefully that's going to be resolved at the platform level, but right now this is still possible. So what did we learn here? First of all those requests triggered by Cloud Manager, or the infrastructure behind Cloud Manager that actually triggers those tests, all such requests supposed to bypass dispatcher cache. And like, it was designed in a way to actually not go via Fastly, as of course that increases the chance of getting some cached object, stale object potentially. which is, of course, not desired, as that's going to break your test. So we implemented a fix in 2 places. In our test suite itself, so it bypasses the cache. But there is also a fallback, just in case someone forgets to do that. So our dispatcher automatically, or Apache actually, automatically injects a few things in the incoming request if that goes to Adobe AEMcloud.net, so it always bypasses the cache. And finally, you should really normalize the host header. As like, if you have a custom domain, I would strongly suggest to check what's going to happen if you request the same thing using that built-in default domain, as that can also result in a pretty funny scenario, as you can't disable those. So those built-in domains, they will be out there. So what we do here is essentially block all requests that go to the default domain. If you want to learn more, these are the links, so feel free to explore. In the appendix to those slides, I will also post a link to a GitHub repository that contains a pipeline that triggers all of that, so you can see how it's been built. And yeah, that's all I had.
Yeah, Henry is curious. Are you also thinking of setting up dispatcher/filter testing to, for example, check the security checklist or known vulnerable URLs?
Yeah, that's exactly what happens. I'm actually one of those folks who do not use the built-in filtering a lot, so I rely really on rewrite rules. But yeah, we check for all those potentially dangerous and unsecure URLs. There's a bunch of checks actually going on, not only for that kind of thing, but also for things that shouldn't be allowed and are application specific. So yeah, that happens.
Then from Tomasz, do you think it would be better to let CDN deal with gzip, e-tags, etc.? I guess you want it there to optimize the traffic between CDN and Apache as well.
That is an option. However, well, technically, it is an option. It's not really a viable option, just because like CDN is just a black box here in the setup. Like you just can't change it in any way. That would, I mean, like that's possible, but that also implies that there will be no compression or reduced traffic between CDN and origin if you're not compressing anything. So that's an option, but probably when you have that bring your own CDN setup. But still, Fastly will be there. So when you have full control over CDN, yeah, that's an alternative, but there are some cons as well here.
Henry would like to know, what is the default domain? Where can we find the settings, OSGI console?
I'm not sure if this is by default exposed to your instance in any way. Maybe there is a way how you can read that, but it's visible in Cloud Manager. I mean, like that's how you normally access your environment. But I'm not sure if this is configured, passed through to the instance itself. So, don't know. It is not. Okay, it is not.
All right, and we do the last question. Are you thinking of open sourcing this as a full-fledged testing library for everyone to use?
I think you can take an inspiration from that repository that I'm going to publish. I do not have a plan to actually build anything that you can just copy. That's like whether you like it or not, it's going to be project specific. So you still need to customize that heavily. So I would consider this as a template that you can copy from and build on top of. So yeah.
Thank you, Jakub.
All right. Thank you, everybody.